Hey guys, good morning. Welcome back to online learning. I hope you were able to enjoy your spring break, if you can even call it a real spring break. I do want to hear from you about how it went. I did post this quick survey on Google Classroom yesterday. It looks like this. It shouldn't take you more than 2 or 3 minutes. I thank you if you've already done it. And if you haven't, again, please take those 2 or 3 minutes to fill that out. I just want to know how your spring break went. Since I don't get to see you guys in person and I miss you, I do want to hear from you. Okay, today's work is CPM Problem Set number 3. So let's get started. I'm going to do, just like in the last CPM video, I'm going to do a couple of parts of the problem just to help you get started, and then you are going to use the examples that I've done. Make sure to include that in your work, and then the other problems are for you to do on your own. But of course, you're welcome to ask me questions about these over email or over video call if you're still stuck. Okay, let's get started. 8-10. In a previous course, you used the distributive property and common factors to change expressions written as sums into expressions written as products. For example, since 6 is the greatest common factor of 12x plus 18, this may be rewritten as 12x plus 18 equals 6 times 2x plus 3. X is a common factor of this, and so you can rewrite this as x times x plus y plus 1. This is basically taking out the greatest common factor like we've been doing before factoring. It's the opposite of distributing, and so that's what we're going to do for A through D. I'll do A and C with you. 4x plus 8. What is the greatest common factor of 4x plus 8? In other words, what is the greatest term that goes into 4x and 8? That would be 4, okay? Not 2. 2 does go into 4x and 8, but 4 is the greatest number that goes into both of those terms. 4 times x would give us 4x. 4 times 2 would give us 8, okay? That is how we factor out the greatest common factor. It's, again, the opposite of distributing. So you want to make sure that your greatest common factor on the outside, when multiplied to the inside, will give you the original expression. Okay. Here, the greatest common factor of 2 and 8 would be 2, but since you have x squared and x, we're going to add that x out front, since x does go into x squared and x. 2x times x would give us 2x squared minus, and then 2x times 4 would give us 8x. Okay, and that's it. So for B and D, find the greatest common factor, and then rewrite the sum as a product. For 8-13, we're going to look at this generic rectangle, write the area of the rectangle as a sum and as a product. Remember, sum is adding up all of the terms on the inside, and then product is writing it as length times width. Okay, two things being multiplied together. I can write the sum right away. That's just adding everything on the inside. 10x squared plus, let's add these x's together. Negative 4x plus negative 35x would be minus 39x, and plus 14 right here. Okay, let's find the length and the width of this generic rectangle. What multiplies to 10x squared? That could be 10x and 1x. It could be 2x and 5x. I'm noticing none of these are multiples of 10, and so we want to use 2x and 5x instead of 1x and 10x. Where should we put those terms? I'm going to put the 5x here since 5 goes into 10 and 35. 2x here since 2 goes into 10 and 4. Okay, this will be a negative 7. This will be a negative 2. Check that works. 5x minus 2 times 2x minus 7. Okay, that's it for part A. For part B, does this generic rectangle fit Casey's pattern for diagonals? Demonstrate that the product of each diagonal is equal. What you want to do here is make sure that 10x squared times 14 is equal to negative 35x times negative 4x. Okay, this is a pattern that we saw in the generic rectangles that we were working with before we started online learning, when we were still in the classroom together. Verify that this pattern works, and then move on. 8-24 says factor. That's taking, again, a sum and rewriting it as a product. So if it's helpful, use a generic rectangle and a diamond problem for each one. I'm going to do part A here. Let's see, x squared down here, the constant term 9 goes up here. Multiply these two to get the top of your diamond. X squared times 9 is 9x squared. The x term goes on the bottom. What multiplies to 9x squared and adds to 6x? That would be 3x and 3x. So you can rewrite this as x plus 3 times x plus 3, or just x plus 3 squared. So you're going to do that for parts B, C, and D. Factor and write the area as a product of the length times the width. Don't forget this piece here, okay? Once you're done with finding the length and the width of the generic rectangle, make sure to write it as a product. Okay, 8-49, factor each special case polynomial. What does special case mean? Special case can be a perfect square case or a difference of squares. If those names sound familiar but you don't remember what they mean, you can go to Google Classroom, go to classwork. I did include some notes for Khan Academy one day, notes about these special cases. I think it's earlier. Let's try Khan Academy Wednesday. No, I didn't mean to move it. Oh, I hate this touch screen. Okay. No! There it is. Okay. Summary of factoring. Yes, it was under Wednesday, March 25th. Here you can see difference of squares. Here's the shortcut, okay? An example with the shortcut, an example without the shortcut. And here's perfect squares. Again, example with the shortcut and without the shortcut. You can solve, factor any quadratic without using any shortcuts. But if you recognize the type of special case that it is, it can save you a little bit of time. So right away I'm noticing that since x squared, if I put a 1 in front of the x squared, it doesn't change the value of the expression. 1 is a perfect square, because 1 times 1 is 1. 64 is a perfect square, since 8 times 8 is 64. Right away, working with these patterns, I can recognize that this can be factored as 1x plus 8 times 1x minus 8. I'm not putting the 1's in front of the x's. It seems a little bit redundant. But this is what it turns out to be too if I just use the generic rectangle and the diamond. Okay, x squared minus 64, multiply those two together. We don't have an x term, so we put 0 down here. 8x times negative 8x is negative 64x squared. 8x plus negative 8x is 0. What do you know? The shortcut works. Okay, you don't need to use the shortcut again. I just want to repeat that one more time. You can use your generic rectangle and diamond to figure out what the product is, but just wanted to show you that. So refer to these notes if it's helpful, but you can do it without the shortcut. Okay, that's 8-49. Let's move on. 8-58. Graph y equals x squared minus 8x plus 7 and label its vertex, x-intercepts, and y-intercepts. I'm pretty sure you had this on the last CPM set. Let's make a table. Let's go 0 through 8. Wow, I can count. Plug in each of these x values into the equation to figure out what the y values are. So for example, if you plug in 0 for x into y equals x squared minus 8x plus 7, you get y equals 0 squared minus 8 times 0 plus 7. That's 0 minus 0 plus 7, which is just 7. Okay, you can do the same thing for 1. Y equals, again, we're plugging in these x values for x in the original equation. 1 squared minus 8 times 1 plus 7. 1 minus 8 is negative 7. Negative 7 plus 7 is 0. Okay, so fill out the rest of the table. Draw your parabola. Label the x-intercepts, the y-intercept, the vertex. Okay. Use the points that you get from the table to graph. Okay, let's see. Compare the two equations below. How are the equations different? Well, one is multiplying and one is adding. So one equation is a product and the other is a sum. Okay, solve. I'm going to give you a hint. For this one, you're going to use the zero product property. And for this other one, you are just going to combine like terms and solve. Okay, what is the zero product property? That is what we use when we have a product that is equal to 0. The zero product property tells us that if you have something times something else equal to 0, either the first factor is equal to 0 or the second factor is equal to 0. So this might look familiar. When you use your product property, set each factor equal to 0. If I set 6x minus 18 equal to 0 and I solve for x, I get x equals 3. Here I get x equals negative 2/3. So I can get 2x values as my answer. I can get 1 in some cases. But we say x equals 3 or x equals negative 2/3 because you can plug in 3 or negative 2/3 in for x, and both of those values will make the expression equal to 0. Okay, for B, C, and D, you will have to factor first. I'm going to do this fairly quickly. Okay, so rewrite x squared minus 7x plus 10 as x minus 2 times x minus 5 equals 0, and then set each piece equal to 0. X minus 2 equals 0. That gives me x is equal to 2 if I solve for x. If I set x minus 5 is equal to 0, and then I solve for x, I get x equals 5. Okay, so do the same thing for C and D. Last problem, examine the graph of y equals 2x squared plus 2x minus 1 at right. Estimate the zeros. X-intercepts of y equals 2x squared plus 2x minus 1 from the graph. Just estimate what these are. Write it as a coordinate. Okay, so remember that for x-intercepts, your y coordinate is 0 since you're on the x-axis. And then what happens if you try to use the zero product property to find the roots? You are going to try to factor this first. And then rewrite it as a product, if possible, and set it equal to 0 so that you can solve for x. Keyword, if possible. Okay, I hope this is helpful. Let me know if you have any questions. You can email me, send me a message on Parent Square. I also have a Google Meet sign-up sheet that I'm going to post shortly after I post the CPM assignment for today. Okay, thank you guys.